Hello everyone. Today we are going to talk about remote procedure call, another programming model for distributed systems. Specifically, if you remember, we were talking about uh, distributed memory programming models, and within that we have talked about several types. We have already talked about socket programming, we have talked about MPI or message passing, and today we are going to talk about remote procedure call or RPC. So RPC is a generic name. However, one of the best implementations of the RPC concept, remote procedure call concept, has been done by Java. And in Java, this is known as RMI, Remote Method Invocation. So it's almost the same thing. So we probably call it mostly RMI. So let's see what is this technology of programming, distributed programming, and how is that done? So we know that for a program, a network-enabled program, because all these distributed programming are network-enabled program. The network, as I talked earlier, network is the prerequisite for a distributed system. So all the network-based, all the distributed applications are network-based. So the same way you can see in this slide that all the applications that we develop, and those are distributed manner, they are either UDP or TCP based, which means that they are network or internet or network based. Because why I say internet? Because all the internet and networks nowadays are TCP based or TCP IP based. So now here we have the application layer. So there is some layers in between. In this part, this layer is part of the application development package. In other words, it's part of Java. And it has facilities for remote invocation or indirect communication, which is probably similar concept. And then it under the hood, it uses methods such as socket programming, message passing, and other ways. But basically, as I mentioned also in other slides, all of these methods are socket-based, right? So they use sockets. So, but they hide the details and the difficulties of working with sockets in like higher level concepts. Okay, in this case of RPC or RMI, Java RMI, that is handled by Java. So basically, this part is part of Java. This layer specifically, the second layer, is part of Java. So it's within the application development package. And before that, I should probably talk about the concept of remote procedure call or remote method invocation. Although this is clear, just the name itself is clear, but it doesn't hurt to say that in remote procedure call, our aim is to build a program that has, of course, method or functions. Well, method and functions is almost the same thing. However, in the context of object-oriented programming, we mostly use the name of method, but it's practically the same thing as a function or a procedure, all almost synonymous concepts. So, the goal of RMI or RPC is to write a program in which the program calls a function like any other program. However, the function that is called, the callee, if you will, does not exist on the same machine that the program exists. The caller exists. In other words, the caller and the callee are on two separate machines. So this is called remote procedure call. And the whole point is to do this transparently. In other words, when the programmer develops a program, that he or she does not realize that a function is being called or calls a function that is not on that computer. So this is technically very difficult thing, but thanks to this RPC and RMI, this is already a done thing. So you can just add some libraries, know a little bit of things that we are going to talk about in this part, and you can do the remote procedure call or calling a function remotely. All right. So let's see how is that done. So this is pretty much what I explained in the previous slide. So we can say RPC and RMI follow a request reply protocol in which we have two programs, which originally could be a one program, but now because it's a distributed system, we consider it as two programs. So the two programs, one of them we can call it a client, and one of them we can call it a server. But in fact, it can be called anything. The naming doesn't matter. So in RPC, what happens is that the caller program, which is the client program, calls a function, like do the operation, and then that function call is handled remotely. Basically, these server and client are on two different machines. So when the function is called, a request message is sent to the server side, and then here the request is received, and then the method is executed, and then the reply is sent. All right. So the good thing about RPC and RMI is that you do not need to develop this part. You do not this part. You do not need to develop this part. You just need to develop this part. You should just tell to the program what you want to do in case that function, in this case do operation, is called. So when that is called, what should happen? So you just put the logic here. And then the rest, like get the request, send the reply, all these burdens are handled by RPC/RMI. And then once the reply message, once the function output is sent back, the program continues to the next step. So if you remember from the MPI section, because it waits, the caller waits until the results come back, we can say this is a blocking approach, right? Because the server, the client, the caller is blocked until the result comes back. All right. So a little bit about client-server communication. I don't think we have much new things in this slide. We have discussed it before, but I'll just go over to make sure we are not missing anything. So client-server communication normally uses synchronous request-reply communication paradigm. It has send and receive operations. It uses TCP or UDP can be used. So don't worry about these things. We are not involved in this level of details. All of these are handled by RMI. So that is the beauty of it. All right. So now let's go deeper and see how this remote method invocation is done. Before that, I should mention one thing. What is the application of RPC/RMI? Because we talked about socket programming as a general thing. You can do everything with that. However, it is too basic and it's a little bit difficult to work with. It's not difficult, but it has a lot of burdens. You have to deal with a lot of different stuff. Then we talked about MPI. MPI is specifically for developing parallel programs for large-scale applications running on large-scale parallel systems, mostly simulations and things like that. So in other words, if you remember from the beginning of this course, MPI is the tool to develop HPC applications, which means HPC/parallel applications. So large scale simulations, things like that, analyzing, let's say, the rocks of an oil field or things like that are done via MPI. But this RPC/RMI has a totally different application. It is not for developing HPC applications. It is for developing applications that are heavyweight, and we have to separate them in different pieces because it is a difficult job for one computer to handle everything. It happens in distributed systems because sometimes the applications are too large, too heavy for the system to handle. I can give you one example. Suppose that we have a data center in which we have several systems, several servers, several racks to do different steps of a workflow. I guess I gave you this example before, that let's say it's a search engine like Google, and for a given request it searches for it. Let's say one system, one machine, analyzes or parses the HTTP header and figures out what is the search query, who is the sender, and things like that. Then the next machine does the search and then prepare the results. Then the next machine packages the results and send it back to the user. So we can see that there is three main operations, and each operation is heavily loaded because of so many users. So now how to make this big application? This application has originally been one big application. How to break it into pieces and making it distributed such that they can work together. They look like a single program, however they work in a distributed manner on a distributed system. So here it is. The solution is RPC/RMI. In this case, for this type of applications, you can break the application into several functions and do each function on a different machine, and then connect them via RPC/RMI. So just a little bit about the application of RMI or RPC. So now let's go back to the slide and see how the remote method invocation or RMI or RPC works. So to understand that, let's first see how is the conventional objects, how conventionally objects are created in Java and are being called and used. So suppose that we have a class A with some methods in it, and then we have a main function where an object obj of type A instantiated. So in fact, from the memory perspective, let's assume that this whole box, is one computer. This is just a conventional program, and we are just talking about one computer. So in that one computer, you know that we have stack memory and we have heap memory. I'm sure you know that. This is not the topic of this course, but you are aware of it from your other courses. So an object specifically is created in heap memory. All right. So when you create an object, it is allocated memory in heap memory. However, and of course it has an address. Let's say in this case 1004, and then the variable itself, the name of the object, in this case obj, is stored in the stack memory, right? And then of course it has a pointer that points to this address, and you work with this object in this manner. So this is a very typical way of working with objects in Java, and I'm sure all of you are familiar with this. Okay, now the problem is that this heap memory in RMI, this heap memory and stack memory, or the name of the variable and where it is really created, are on two different machines. So here is the challenge. Basically, we have the same program, class A, main function, and then we have stack memory and heap memory. However, the only difference is that there is a big interconnection on these two machines, between these two machines. That means that they are not they are not located on the same memory, space. So this makes things very difficult. All right. So let's see how is this magic handled by RMI. So in this case, and by the way, don't forget that we want everything to be transparent. Here, transparency is the core. In other words, when we do the client-side programming, we should not realize if the function that we are calling is local or remote. So that has to be totally transparent, or transparent to the extent possible, better to say. All right, so in this case, what happens is that again, the function call the memory allocation happens on one machine. Let's say this plays the role of heap memory. And then don't forget that it is possible that other instances of the same class are built. So in other words, what I'm trying to say is that we may deal with more than one instance of one class. Okay, and then we need the client side needs to know about, basically doesn't need to know anything or doesn't want to know anything about the remote side. It just wants to know that in a transparent manner, that it just wants to play with this object variable without knowing where has it been located or allocated memory. So it wants to work in its conventional way. However, the implementation is different. It is implemented, or it is allocated on a remote memory. So what happens, the trick is actually not too difficult. What we need to do is creating some or simulating, if you will, some sort of shared memory, some kind of a blackboard that is shared between these two. Because when I say shared memory, it reminds us memory and then some sort of shared thing. This is more like a shared database, if you will, and that's called the registry. So this is the magic of RMI. So basically what RMI does is that it gives the new object a new name, let's say X, and then it is loaded on or it is listening to a certain port number. All right, and then this, so basically this is called the registration process. So basically the only difference is that when you work with RMI, you have to register the object that is created. All right, in the registry. So Java gives you the ability or the classes needed for registry. You do not need to create that. You just need to register in that registry with a certain port number. And then once that is done, the client side, the address can be obtained from this registry. So basically it says that I want to work with X, and then on that specific port number, and then the connection is built. So that is the way, in fact, RMI works. So basically, it is possible to do a chain of remote procedure calls. In other words, one application can do a RPC to another application, and then that application can do a remote invocation to another application. So there might be a chain of several calls, and that is the beauty of it. It's like that you can make basically a workflow. All right. All right, so now let's go one step deeper and see how to implement an RMI-based application. So I should say that in this case, interfaces in Java specifically play a big role. The whole point behind the abstraction that is created for users is with the help of interfaces. All right, things that should be done are as follows. So you have to create a remote interface. All right, it's also known as a skeleton. So this is the services the functionalities that are provided remotely, right? So you express the list of functions that are going to be offered to other machines. This is what it does, the remote interface. And then, of course, on the server machine, this remote interface happens on the server. And then on the same machine, you implement those services. So it's called the servant component, which implements the remote interface. And then, of course, you have the server component, which you can think of intuitively as the main program of the server side. In other words, this really instantiates from this servant class, because this is just an interface. It doesn't do anything. Servant is just the implementation. Again, it doesn't do anything, or better to say, it does not instantiate itself. So this server component is not a difficult thing. It's just a program that instantiates from the servant program. And then server program, in addition to instantiating from this class, also it does the registry. This is important. It does the registering that object into the server class. And then once the registry is done, then the client application can connect to that function and does the remote procedure call. Okay, I guess I explained all the things here. This registry is also called binding, so just terminology wise, please be aware of it. Okay. Another point is that once you implement the remote class, then of course you can instantiate it locally and or do the remote method invocation. In other words, or in addition to that, a class can expose only some of its functions remotely and keep others locally. So you may have a class that have some functions that are just available locally and some methods or functions that are just available remotely or available remotely. They can be called locally too. Okay, the binder is just a registry. Client program requires a way to obtain the reference of the remote object in the server, and it uses the binder class. Okay, so a binder maintains a table, as I showed, the registry table, that enables it to create a class from textual names as opposed to addresses, because address here doesn't make sense anymore, because the address is the address of a remote computer, and that's not valid. So we have to use textual content. If you remember, that X in that example was a textual thing, and then we create an object out of that. Okay, and then server has to register the objects that are created and wants to expose it to be used remotely. Okay, so this is a very important slide showing you kind of visually all the things that we explained. So we have three components. We have client, we have server, and we have registry. Okay, so on the server side, we have at least two components. One is server, like the main function, and then the remote object, and the rest of the things, and the client side. So these are the bare bones of what we have here. All right. So what the first thing what happens is that using that skeleton, that interface, we use that interface that basically does the exposes the functions that we want to make them accessible remotely, and then an object is created, like what you can see here, step 1. An object is created of the function that we want its method to be exposed remotely. And then in the second step, it's very important, you bind that remote object that is created in the registry table. So you bind, let's say my RO, my remote object, with the address of it. Okay, so you register it in the registry in this manner. The name of the class, the name of the registered name of the object that you want to call, and then once you know that, you can get the access to object, and then via a proxy, it's called the proxy class. You do not see that, but it is created. Via that proxy, you can call the method. So you do not realize from this point onwards, you do not realize, because the invocation just happens as if the function is local, not remote. And then the function call happens, and then the chain of call happens. You do not see any of these, and just you get the returned value. All right. So I should say that, speaking of like a little bit metadata about the RMI and RPC, so as I said, like transparency is the main objective in RPC and RMI, so that your program is just written as normally, but it's executed in a distributed manner. So both location and access transparency are important. Location transparency means that you do not know where the functions exist or being called. So that's called location transparency. You don't know where object A is. You just call it. And then access transparency means that when you call it, you just call it as if it is a local thing. So you don't know where the object is located, or allocated memory. So that's location transparency. And access transparency means that you just call it as if it is a local thing, and then all the finding of that object and calling and all those messages are handled behind the scene. Okay. However, I should mention that RPC is very much prone to failure. So specifically when you compare it with a local thing. So if you have a local program, or everything together, all the functions and classes and methods together, so if you call a method 100 times, probably nothing would happen. But once network is involved and RPC is involved, the chance of failure is much higher. Therefore, we have to incorporate some knowledge of it to the user, so that user can, the programmer here, by user I mean programmer, so that the user can prepare the program for that situation, for the failure situation. For example, some exception handling things, such that if the request fails because of a network thing, we do an appropriate action. So we compromise, or Java compromises a little bit on transparency to make it more practical, and it involves the programmer a little bit into the RMI procedure, such that error handling and things related to failure can be handled. Okay. All right, now let's see an example of an RMI remote method invocation. So let's do a hello world program using RMI. So don't forget that, we are starting on the server side, don't forget that. And then, of course, in the beginning, we have to import the RMI packages that include everything that we need. And then we have to develop that interface, that skeleton, if you remember. And it extends remote, so it connects to these packages that we imported. And then let's call it hello server. And then it has a function like echo. So it's just a hello world that whatever you send to the server, it just echoes that. And then it throws remote exception. You can see here we compromise a little bit on the transparency, because you have to deal with things like remote exception or remote package. Okay, so now we have done, this is what we exposed, the echo function. In the next step, we have to implement the servant class. So this is the implementation of that interface. So basically class server, let's call it, whatever name you like it, implements hello server. So that is the thing that the interface that we implemented in the previous slide. So this is the function that you have to implement. You have to override the echo function that was mentioned in the previous slide. So here, just add whatever string you receive, you add an IAM server to it and plus input, and you return it. So basically, very, very simple logic, because our focus here is to show how things work, not the algorithmic complexity of it. All right. So in the next step, we create the server application. If you remember, the third component is the server application. So it's still within the same package, of course, and it imports the same set of packages. And then it's the main part, the main program of the main function of the program. So first thing here is to create a registry. It's a static function from locate registry class, and then this is the port number of it that you create, and then of course the registry becomes a variable. And then from the server class that we implemented in the previous slide, you create a new, you instantiate from that, and you bind it to the registry. Okay, so and you give it a text name, hello, like my RCO, if you remember. I guess it was RMO. Okay, so you give it a text name, you instantiate it. This is the step to add the class into that table, to the registry table. And then, of course, you say that server is bound. So here the server part is done. Now the client part should connect to it and does the function call. Okay. Now let's go to the client side. On the client side, you don't have to do much. Of course, you are still the package of registry. You do the imports, appropriate imports, and then you just have a main function. First thing you do, because you want to call the function, you do the lookup in that table. If you remember, that table was on port 10,000. And then if you remember, I mean, not remember, but in this example, it has been done on localhost. Of course, if you are going to run this on a remote machine, here you put the IP address of the remote machine. And then, so RMI is the protocol, and then colon / localhost or whatever IP address, and the port number that we assigned in the, this is the port number of the registry. And within that, we want the class hello. That's the text that we gave it. So it's a Java class naming. So we do the lookup. Basically, this deals with the registry. And then once we extract that variable, we have to cast it to hello server. And hello server was the name of that interface, if you remember. So we get a variable of type HS, as of type hello server, and then let's say our input is cloud, and then I do hs.echo. So here is the whole point. You do echo, you call echo as if it is local, right? In the invocation level, you do not see any difference. It's totally transparent. and then the result comes back. Yes, this HS is called the proxy object. It's not a real object, it's a proxy object. All right, a few points. Now your program is done. Now how to run it is the next question. So typically there shouldn't be any question for how to run it, but there is a little bit of things to explain. The point is that here we have two computers talking to each other to run one program. And then always these firewalls and security settings make problem. So therefore you have to do some setting to avoid those problems. So basically you have to create for Java, this is for Java specifically, you have to create a policy file. It's called the policy file. And then in that you have to grant access, in this case to give all permissions just to make the test happen. And then on the server side, you run the application server program, of course using Java and using that policy file. This is what we discussed here. And then similarly on the client side, you call the client application, and then of course Java, and then the policy file. All right, here we completed the RPC RMI section of this course. Next session, we are going to talk about web services.